Ryan here. Web server logs are really a great candidate for reducing your log volume. And so I want to show you kind of some practical ways we can start to do that today with an NGINX web server I've got running. You know, we've done a few videos on kind of these individual components, and so I really want to just start to put it all together, so you can start thinking about how you can do this type of reduction in your own environment. And so on the left here, we're collecting NGINX logs, sending them off to Splunk and Grafana. We've got pretty good volume here, and so I want to start to add some processors to kind of increase the signal and, like I said, ultimately reduce the log volume. So the first thing I'm going to do is I want to create some metrics out of these logs. So BindPlane lets you turn logs into metrics in the pipeline, which means if you're getting enough information from those metrics you're creating, you can actually drop the logs. And that's exactly what we're going to do. So as always, let's kind of jump in to an agent and take a look at our snapshot here and see what the stream looks like. See, we've got a decent amount of info logs coming through. And what I want to do is I want to create two metrics. One is going to be the number of logs I'm getting dimensioned by status, and the other is going to be the number of logs I'm getting dimensioned by request URL, so we can see the path of the request. So let's do that now. Go back to our config here. And the process we want to add is called count telemetry. So this does exactly what the name suggests. It allows you to count the telemetry coming through the pipeline and emit that as a metric. And we want to count logs in this case, which is generally kind of the most useful. And I'm going to do just a little copying and pasting here, but this match expression is just identifying the logs you want to match on. So it defaults to true, which means it's going to count everything. I want to count everything except where the status is not nil. So I want to make sure that there is a status before we count it. We're going to give this a friendlier name, nginx.request.status. We will keep the units the same, and then I'm going to enable attributes, and this is how we can start to dimension the data. And so put in a key of code, and the value I want to populate is the attributes.http request status. And we'll take a look at exactly what this does when we see the resulting metric. Finally, down at the bottom here, we can set the interval, the collection interval. 60 makes sense and it is a good place to start. I've got really high throughput right now, and for the sake of the demo, I'm going to set it to 1 second just so we can kind of quickly see the metric. If it was set to 60, we would have to kind of sit here and wait for a bit. So let's do that. We'll save it. We've got our processor now. And check our snapshot, and boom, there you go. You can see we've got a new metric called nginx.request.status. Here's the value, and here's that attribute we created, code, and then it pulled the value from the log. So this has a status of 500. So that's awesome. So now we're sending that metric off to Grafana Cloud. So let's do that one more time. Again, we'll enable logs. And I mentioned we want to create a new metric for path. And so in this case, I want to actually just count everything. So we'll leave the expression as true. We'll call it request.path. The attribute, we'll call path. And I'm grabbing the attributes.http request URL. And again, for the demo here, we'll set the collection interval to 1 second, but 60 is a really great place to start. Awesome. Okay, so we've got these two processors here. Again, let's validate that worked. Come in here, and there you go. See, we've got a new metric called request.path. There's the path, and there's the value. V1 delete, and here's the value. Awesome. So now we've taken those logs as they've come into the pipeline, and we've created some metrics out of it. So we're increasing the signal. And in our topology, right here, we're seeing the log throughput, right? If we jump over to metrics that we see at this processor node, we're starting to generate metrics. And so this is where, that logs to metric processor is coming into place. And it's sending those metrics off to our Grafana instance. So this is really great, and it's, you can see the size is obviously really small. Okay, so we're creating metrics. Now we want to drop some logs that we don't care about. And specifically, we're going to drop health checks. And so I want to add a filter. In this case, it's going to be the log record attribute filter. And because we want to drop them, we're going to set the action to exclude, and the match type will be strict. And we want to drop everything where the request URL is /health, right? So we'll save that. And there we go. You can see that processor's been added. And we'll give this 10 or 15 seconds here. But what we should start to see once this refreshes is a pretty decent sized drop in our log volume now, maybe 10 or 15%. And yep, so there you go. You can see kind of the input here on the left, just under 1,000 kilobytes a second. And then on the right, just a bit over 800. So this is updating every 10 seconds, but we're seeing log reduction now. So what we've been able to do in BindPlane is take these logs, create really useful metrics from them, so we're still retaining that signal we care about, and then just dropping the logs we really don't care about. In this case, I didn't need to see all the health checks, as long as I knew how many I was generally getting, which we were doing. So that's it. That's a really basic example of how we can start to use BindPlane to do data reduction and increase the signal in your telemetry. Hopefully that was helpful. If there's any kind of other use cases you want to see, let us know. Would love to look at kind of some specific sources, and we can walk through some other tutorials. See you next time.